The Green Box was a system intended to allow consumers to create an entire alternative energy system even with the minimal knowledge of electrical engineering. This project strived to allow for the easy integration of up to 3 power-producing devices. The user has their choice of wind, solar, human, or any other type of green power in any configuration. The system also stored on any energy generated and provided familiar interfaces to the consumer that allowed for easy and practical use of the energy. Please welcome the Green Box team.
Hi, good morning. My name is Eric Eierman. This is Al Calhoun. We were two of the members of the design team for the Green Box. The idea of the Green Box is really as a portable green energy generator. Could be used during natural disasters such as hurricanes or camping trips, boating trips, that sort of thing. Some of the advantages are its design is small, allowing it to be portable, relatively inexpensive, and easy for the average consumer to operate and use. Ultimately, our main goal was to bring green energy to the masses. Some of the other project goals were flexibility and portability. We wanted the inputs to be interchangeable so the user could decide which sources of energy they'd like to use. If they live in an area such as Arizona where solar power is kind of the big thing, they could use 3 solar inputs, or if they're in North Dakota, they could use 3 wind turbines, or any combination. We also, another goal, we wanted to make it efficient as possible, harness as much of the power generated as possible, and turn off unused electronics when not in use to avoid wasting much energy. And then also safety was another goal. We wanted to, we put in alarms to alert the user to avoid any possible damage to the electronics or harm to the user themselves.
All right, now I'm going to talk a little bit about the system overview and how we actually designed the system. First of all, we decided to use 3 different inputs. So the user can decide the user can decide between using solar or wind power or hydropower. It really doesn't matter. We also created a human power mechanism so you can, with your legs, create up to 100 watts of energy with our bike system. We made it very robust, our inputs, so that it can be put into the system. It doesn't really matter. That's the point of the project. The outputs, we chose the 3 most common here in America. Most powerful is also the 110 volt AC, which is good up to 1,000 watts and will support any load, even in an inductive load such as a refrigerator or a small air conditioner. 12 volt DC for all your car electronics. If you're on a camping trip, you can take a solar panel and that, or if you're at a tailgate party, yeah, there you go. You can also take the Green Box out there with a wind turbine or whatnot. We also have a 5 volt USB port for iPods or any type of MP3, or computer electronics usually run off 5 volts. Next, we decided to include a battery, so instead of just instantaneous power, you can store energy to use at a later time, such as if it was in Florida and you're using solar panels only, you don't have power at night, so you can use the power to produce it at night. Then finally, we have an LCD display which took in diagnostic and performance information and presents that to the user. And it presents various parameters such as current coming in, current going out, and we're also displaying how much money that you're saving or projected to save instantaneously. And then we also present a cumulative report of how much money you've saved over the whole course of owning the Green Box. Now we're going to do a cost-benefit analysis. The cost of the system, all the parts, was $1,500, except if it was done in mass commercialization, it would be around $900 or cheaper, depending on how many units were made. The maximum power production would be 1.26 kilowatts. Now the maximum energy, assuming perfect conditions and that the wind is blowing all the time and you're getting max energy, would be, you'd save $1,400 almost per year. So in the end, it returns itself in price pretty quickly. but this is also assuming that the price of solar panels or wind turbines are not taken into account. So I'd like to thank Progress Energy and all the faculty of UCF for supporting our project, and thank you all for your time today.